Good morning, everybody. Good afternoon if you're not in the Western Hemisphere. Good evening. Thank you for attending the InduSoft Web Studio Vision Systems webinar here. Today we have a special guest, Mr. Rob Fell from Omron. And my name is Scott Courtier, and I'm the Marketing Communications Manager for InduSoft. Today we're going to be covering vision systems and how it relates and ties into InduSoft Web Studio. I'm going to give you a brief introduction to InduSoft and what the product is. We'll cover some of the main product features in InduSoft Web Studio. We'll talk a little bit about vision systems and how InduSoft can connect to any vision system through multiple connection mechanisms. And then we'll go into Rob's presentation regarding machine vision basics, vision sensor applications, managing successful installations, and he'll cover a real installation of using Omron Vision with InduSoft Web Studio. So before we get into the main product features, InduSoft has been around since 1997, and we were the first in the industry to have Windows CE based HMI and SCADA system, as well as web-based, being able to publish screens remotely via the web. We've won numerous awards, and we're a full HMI and SCADA software package. So a lot of people think of us as either SCADA or HMI, but they don't realize that we're very scalable and that we can cover full ranges from very low tag count to very high tag count. So from about 300 tags, or from 300 tags all the way up to 10 million tags. So, and the feature set pretty much stays the same across all those different levels of licensing. We run on any current Microsoft operating system, 32 and 64 bits, including Windows CE, embedded versions, Windows 7, server editions, and soon, as it's released, Windows 8 as well. The product, InduSoft Web Studio, and the various license formats of that via CE view or embedded view are very scalable in the fact that it's the same package whether you run it on a mobile device, an HMI on a desktop type operating system, or even as a SCADA system on a desktop operating type system, or all the way up into a SCADA system where you might be managing and monitoring entire lines, processes, facilities, or even across multiple continents as well. The product was designed to be compatible moving forward. So if you were to take a project that was developed in InduSoft Web Studio CE View 1.0 back in the late 90s, you can even get that to come into version 7.1, and it will run 100% compatible. So connectivity-wise, and this is going to be important as we get going into some of the conversations that I will cover in a moment, as well as Rob will cover in a little while. The connectivity that's built into InduSoft Web Studio. If you look at this diagram and you see InduSoft Web Studio in the middle of this diagram, there's a lot of different connection mechanisms to get information in or out. Notice that these arrows are bidirectional. We can get this information in or out of InduSoft Web Studio. Very traditionally or very typically, a customer might use one of our over 240 built-in drivers to communicate to any PLC that you could imagine. So you can see a list of here: Omron, GE, Allen Bradley, Siemens. So the list goes on and on and on. There could be a DCS system. So in addition to the existing drivers, we have OPC connectivity. So that could be OPC DA, which is commonly known as OPC Classic, OPC UA, which is more of the new standard that OPC Foundation has come out with, as well as .NET and XML and some other variations that OPC has. So if you don't have if InduSoft does not have a driver specifically for the particular device that you want to communicate with, OPC is an option as well. We can communicate via the web in a few different ways. We have the ability to run InduSoft Web Studio directly on Windows mobile devices, and that is one way. But via the web, we have 3 different thin clients. Those are called Web Thin Client, Secure Viewer, and what we call mobile access. And mobile access allows you to run on any web-enabled device. It could be Android phones or tablets, iPhones, iPads, Blackberries, you name it. And we can get into variations of that via text-based, or what we call tabular, or graphical-based, that'll run on HTML5 enabled devices. We can also use InduSoft as an OPC server, or communicate to devices via TCP/IP and various variations of that. And then we can also use XML as well as different database connectivities to connect to different databases. InduSoft Web Studio will connect to any SQL relational database. It could be Microsoft SQL Server, but it could also be a MySQL, could be Oracle, could even be Microsoft Access or even Excel, historians such as Pi. And then we have an open architecture so that we have toolkits that are available that if we don't have a particular connection mechanism via one of these, you can write your own connection to as a driver, or right into our tag database. So there's a lot of different connection mechanisms, and we're going to touch on these in a moment as far as how to use these related to vision systems. So when we talk about vision systems and some of the capabilities of various vision systems, generically what I want to talk about is, in general, vision systems take on many forms. Vision systems can be simply a pass-fail inspection, so that's all you get is a yes/no, or it passed or it failed. Very typically used in a part-present type of notification. For example, is a screw in place? If you're supposed to have 4 screws holding something in, are only 3 of those there? That's a failure. Or all 4 of those in place? And are they screwed down? Is it just a little bit out of center, or does it look like it's maybe not screwed in all the way? Are caps completely on bottles? You can take a side view of a capping line and see, is a cap on the particular bottle. A locking pin, maybe there's a safety issue and you want to be absolutely sure that a locking pin has been placed in. Or maybe, for example, pills in a blister pack. Are all the pills in every one of the little blisters that they're supposed to be? Another example might be tolerance detection. There might be a range of measurements that can be allowed, and if it's out of tolerance, then you want to put that eject that part into an inspection bin, so maybe somebody else can take a look at it visually and determine if it's good or bad. Measurement or gauging. We'll show a small screenshot in a little bit that shows maybe exact measurements. So taking measurements of are things the right size that you expect them to be. Eliminating human eyesight and potential missed bad parts by human scanning of that. Barcode and data matrix, or 2D barcodes, are another implication of vision systems as well. And optical character recognition, or OCR, which is actually reading the text or turning an image into text. And there are many other formats, but these are some of the more common ways that vision systems can be put into place. And here you can see in this little screenshot there's a camera, and it's showing an inspection of a printed circuit board. So maybe there's an IC or several capacitors or transistors, and just very quickly that you want to make sure that all those parts are in place. Where if a human was looking at this board several hundred times a day or several thousand times a day, there's a chance that they will miss that, where a vision system will not. So taking those systems that I just mentioned, or those types of applications for vision systems, and explaining those in a little bit more detail. Very often in a pass-fail, that's a Boolean operation or a bitwise operation, where from the camera we might be able to see just a software bit. Is it on or off? And we can represent that on a screen, on an InduSoft Web Studio screen, as a pass or a fail. Very clear, is it correct or is it not? And in the case where maybe you get a failure where you're not seeing something that should be there, then maybe you would get a graphic of the actual part on the screen, where that would come right out of the camera and be displayed on the InduSoft Web Studio screen, so that you could see what was bad, and it might highlight that particular bad area. Talking about tolerance measurements, or measurements in general, tolerance and or measurements. You might measure distances or radiuses. For example, the radius of the center of a compact disc or a DVD might be something that would be inspected, because if that center circle in a DVD is not the right size, it's not going to play in a DVD player. So that might be something that gets inspected as it comes off an assembly line. And very typically what you will get back is millimeters or inches or the actual measurement. And how does that come back? That might come back in as a PLC protocol for InduSoft Web Studio to request data directly from the camera. Some cameras, some vision systems might be able to be connected to InduSoft Web Studio via a driver that we have, or OPC, and get the information directly out of that. So here you might see, here's a screenshot of a vision system where you might see the depth, the measurement, and it can actually detect the edges or the spacing between different things, and give the actual measurements, and then you can keep track of those, either log those in a database, or if it just passed, then send it on through and maybe you don't have to keep track of it. We've all seen barcodes on food-related products in the grocery stores. 2D matrices, matrices are becoming more and more popular, where you can, in a square inch, capture several K worth of information, essentially whole pages, documents in a single square inch or slightly larger. And how those will come in is sometimes those will come in via USB port and just look like a keyboard coming in, or perhaps the data would come in as a PLC protocol using an InduSoft Web Studio driver as well. So if we were to also take a look at some of those connectivity options and how they might come into InduSoft Web Studio, I just kind of described some of those, but what you might have is a camera directly connected to InduSoft Web Studio using one of our built-in drivers, such as Modbus TCP, Ethernet IP, could be Omron, fins, could be various communications drivers as well. Another way might be the vision system itself might not have a PLC protocol, but it might act as a sensor where it's a switch, an on or an off. And in that case, it might tie in directly into a PLC input, and then we might use a PLC driver to communicate to the PLC and get the information directly from the PLC as opposed to directly from the sensor itself. There are certain types of cameras that have ActiveX configurations, so that within InduSoft Web Studio you could put their ActiveX configuration object on our screen that would allow you to directly tie to the camera to configure it and then tell it to start or go and run its particular profile. Another way through a vision system might be to have an OPC server built into the vision system. Then InduSoft Web Studio would be the client, which we could communicate to the OPC server built into the vision system and communicate to it directly that way. Another way might be as a keyboard input, excuse me, or via Wi-Fi directly to some type of barcode scanner or 2D data matrix as well. So those are all different variations, and those can be used in combination together or singularly to get information in or out of a vision system and make an application much more effective and efficient, being able to detect certain parts missing and not miss those where human intervention might actually miss those. So what I'm going to do now is hand over the presentation to Mr. Rob Fell from Omron, and he's going to present his type of application on this, and hopefully you enjoy this, and we'll hand it over to Rob now. And we'll hand this over to Rob. And we'll unmute Rob. Or Rob, if you can go ahead and unmute yourself there.
Alrighty, can you guys hear me?
Rob, I can hear you just fine. And there's your desktop. Great.
Beautiful, beautiful. So thanks everybody for attending today. Thanks Scott for the invitation. Excited to be here and share a little bit about Omron Machine Vision and our integration with InduSoft. Hopefully the content should be valuable for everyone. What we're really primarily going to be focusing on is not necessarily the bits and bytes of vision, but understanding vision itself. A little bit of introduction to Omron. Managing a successful vision application, which is really a very key part of this. When you talk to people who have had experience with machine vision, you usually get one of two experiences. It's the person who it does exactly what they wanted, and it's functioning, somewhat flawlessly, and they don't ever have to touch it. And then you have the other side of it, which is, the customer who does the implementation that probably didn't start out on the right foot, and vision is one of the things that's, if it starts out wrong, it's probably going to continue wrong. So we're going to talk a little bit about managing that process. And then, last and one of the key parts is leveraging InduSoft for different machine vision applications. And, essentially, not to steal my own thunder here towards the end, but, really what InduSoft does is takes machine vision and inspection in general, and it changed it from identifying the problem to providing the information and data collection to potentially start to actually deal with the issue, which is really at a manufacturing level what you want to do. You don't want to just always identify the problem. You want to figure out how to fix it. So InduSoft is going to help take us to the next level there. So just a little bit about Omron. For those of you who don't know, Omron is an extremely large organization, about $7 billion, 32,000 employees. A little under 40% of our business is industrial automation, and the balance is custom products and the healthcare division. So sales offices in over 80 countries. So the key is from a support perspective. We're really nearly second to none when it comes to global support and our ability to follow projects, applications, solutions, and customers wherever they need to go across the globe. So, and then one final part I just want to point out is a real key feature here. We turn around 7% of our gross revenue back into R&D every year, and what that means is constantly re-releasing new and different products. And Omron's also distinct for large manufacturers anyway, in that we own and manufacture right around 98% of what we put on the street to our customers. So that's a rarity, and especially in this age of co-manufacturing and such. And really what it leads to for our customer base is quality standards that are somewhat unbeatable. So, and then we're talking about Omron today, but really we're talking about vision today, but really Omron is an automation company. We don't dabble in anything. In any product suite that we have a full offering from controls, motion, vision, inspection. For those of you who don't know, we actually purchased STI a number of years ago. STI was North America's largest safety manufacturer. So Omron has an extremely large and comprehensive safety offering as well. So, when we approach our customers, we really approach them holistically to look at what the problem is. We're not burdened by the fact that we have to deal with one specific product or one specific solution. We can really look at what's best for the customer and then build our portfolio of products and solutions around that. So. And then finally, the part that, excuse me, I didn't really introduce myself. I'm actually part of our strategic accounts group, which is a subset of the business development group. So some of the interesting offering that our group specifically brings to the table, most appealing to the end user level, is that there's very few, actually none that I'm aware of actual manufacturers that will take factory responsibility for designed, integrated, and installed turnkey vision solutions, and we are one of them. And that's essentially what my project or what my group does, and why I was asked to come here today. Is that's really our area of expertise. So it's international project implementation and resource planning. Within that subset, fully turnkey solutions, and then we take on factory accountability for that. Does that mean Omron is an integrator and Omron is a design firm? No. The truth of the matter is we understand machine vision. We understand how to manage that process. So we have partners that we work with that are experts in their given field, and then we make that collaboration and make that transparent to the customer to provide that turnkey solution and then take responsibility for it. So a unique offering, especially for the end users that are dealing with typically a very decentralized support structure. So let's talk about something near and dear to my heart, machine vision. Personally, I've been selling machine vision for 13 years now. It's an amazing product if you understand it. Its value is really unquestionable when implemented properly. Machine vision at its core, this is the Wikipedia definition of it, which, like everything on the internet, of course, is correct. But the watered-down version is, it's a sensing device that takes in an input. It's a processing device that deals with it, and then it's an output device that actually is going to give you some sort of signal like Scott pertained to, whether it be discrete signal, some type of a data exchange. So on the front end, it's camera. In the middle, it's typically a processor type device, and then some type of output, either through Ethernet, serial, or discrete communications. So when you talk about the keys to vision, the cliche that you'll hear is lensing and lighting are the key to machine vision applications. There's a fair amount of truth there. The reality is, as is the case in a lot of the automation segment, the major suppliers of machine vision equipment, in all reality, have very similar offerings. Each of us has our own distinct advantages, but the reality is we all kind of do the same thing. We just do it a little bit differently. So the real key is the lensing and lighting is a very important part of it. But the one thing that goes unnoticed that I wanted to make note of, for those of you who are either considering moving into implementing machine vision, or you're stuck in a project right now that you just can't get out of because it was mismanaged from the beginning, is experience is so key to implementing vision projects the right way. So lean on your local resources, lean on your local Omron, factory engineers, your distributors, tech documents, things like that. Talk to people who have done it. Vision carries this kind of bad connotation is black magic and sort of this unknown voodoo science of trying to make everything work. That's absolutely not the case. The difference is that, like in any segment, people who have done it before understand the pitfalls. They understand the nuances. They don't get it to the point that it works by luck. They get it to the point that it works because they understand the fundamental scientific background behind the reason that application is actually successful or not. So lean on your own application engineers and local support to get those things accomplished. So let's talk a little bit about, and forgive me for those of you who have gone through this, and this seems a little rudimentary, but for those of you who haven't, there's really just, I don't want to get too much into the technical side, but there's really, three kind of major terms in vision to be aware of as you start to go through the process of understanding machine vision. So field of view is if you were to basically close one of your eyes and look at a wall or something like that, the entire area that you're seeing as it relates to a vision system would be that entire area. So it's really your entire field of view that you're looking at. In this case would be considered the blue square. And then more specifically is the region of interest. So within a particular field of view, what is the region of interest? And what are you specifically interested in those areas? So you can have, typically when you have a larger field of view, you have multiple regions of interest. In this case, you can see the 4 individual yellow squares, and then the actual target that we're looking for is the red star within that. So hopefully pretty basic, pretty clear, but just from a nomenclature standpoint, it's important to understand field of view, region of interest, and the distinction between the two. And then this is a part that tends to get a little foggy with people. When you talk to a machine vision company, and even when you're trying to evaluate your own application, the context of resolution usually gets thrown around inappropriately. So if you talk to a vision company and you say, what's your resolution, and they respond with a number, they're wrong. And the reason is because that number and that resolution is always a function of the actual pixel count of the camera and the field of view. So in this case, just to show you, standard camera, which is a 640 by 480 pixel count, field of view 4 inches by 5 inches. So the resolution is basically, dividing some dimension by the associated axis of pixels, depending on the aspect ratio of the camera, or more simply, which way you have it turned, right? So in this case, if we turn our camera in the direction of the 640 pixels across the 5-inch axis, we end up with 0.0078 inches per pixel. And then in the case of the 4-inch, you can see it's 0.0083. So is this our minimal detectable resolution? Yes. Is this the minimum stable detectable resolution? No. What Omron typically does is takes this number, this 0.0078, multiplies it by 15, in order of 15, and that's what we consider to be a stable, consistent, detectable minimum object. So whether it be a defect, whether it be a gauging or measurement application, that's our That's basically what we kind of go to market comfortably with, is saying. So if you're thinking in your heads, well, how do I then, without making a larger investment in a higher resolution camera, get more higher pixel count camera, get more resolution out of that camera? Well, if you look at the equation, it's essentially decrease your field of view. So when you're tuning into a particular object, you really want to focus in on the key part of that object as best as possible, because you're going to get the highest resolution with the smallest field of view. So let's talk a little bit about system configuration. There's really 2 or 3 primary configurations. This is your average vision sensor configuration. So the beauty of these is that the hardware is extremely streamlined. The lighting, the lensing, and the smarts of the camera, so to speak, are typically all integrated into one housing. In this case, we show a small separate setup tool that's not required for the system to run, because everything is actually stored within the camera. So streamlined hardware. Typically, these are lower cost type items, anywhere between $1,500 and $4,000 per se. Somewhat limited from a lensing and lighting perspective. When I say limited tool set, they're actually quite capable, but as compared to other higher end versions, at least within our own vision offering, the tool set is not quite on par with some of those. And it's typically single camera inspection. So these are extremely capable in very application specific situations. So typical vision sensor applications, is something there or not there, or is there a particular quantity in the case of the pin counting here, off the terminal counting? Edge position. I would tread lightly with edge position in a vision sensor. When you get to the point where you're really doing a higher end gauging or measurement, these really aren't the perfect solution for that. But as it's illustrated in the edge position picture right here, what you're really talking about is looking for a gross defect if the cap was missing or completely off. Width, as Scott had pertained to as well, again, I would keep this in the category of general or gross changes in width, and then even some character identification from the perspective of a pattern match. So this is an OCR or OCV, which is optical character recognition or verification. This is actually just a highly sensitive pattern match. So kind of the next level up from that, and again, what I'm trying to kind of build here is a picture. So is the next time that you try to give consideration to implementing machine vision, you can kind of look at this in a few different ways and say, what's really required of my application, and where should I start with, and it helps you with the starting point. So in the next configuration, this is essentially a box-style controller. So different vision companies go to market a few different ways. Some are of the belief that everything should be consolidated into the camera itself. Omron historically, and now we have a little bit more diversification, but historically has taken the stance of, we'd like all the smarts to be in our controller, which is safely placed in a control cabinet, and then we keep the lower cost, somewhat dummy camera, for lack of a better term, out in the exposed environment. In the case that something potentially happens, it's a lower cost replacement for the customer. So in this case, box-style controller, multiple outputs and inputs with regards to Cat5 cable, USB, serial, Ethernet, up to 4 cameras as far as the connection goes, somewhat flexible. There's a multitude of different cameras and lighting options available, mid-range from a cost perspective. The tool set is extremely capable, and then, as I mentioned, up to 4 cameras per controller. And in all these cases, you have to feed back to something, right? So whether it be as simple and discrete as a reject mechanism that you're just giving a direct output to a relay that's triggering a solenoid or something, or if you're actually communicating either Ethernet or digitally to a PLC or PC. So different types of applications, again, just the next step up. Character inspection. So this is actual character inspection and recognition. Counting. So the labeling tool is a really interesting tool. You can actually identify, one of these squares with a white circle is considered a label. And then what the system does is it goes out and seeks for X amount of those images within a given field of view. So you don't necessarily have to tell them where they are. It'll actually tell you how many are there per the model that you set. capability of more intense defect tools, and then more comprehensive measurements as well. So really the kind of future of Omron Vision is, in what we've seen, is moving towards really a system that plays extremely well with InduSoft, which is our Giggy Base or gigabit Ethernet-based camera systems. So it provides a lot of flexibility from a hardware configuration. It's also extremely streamlined in that it's essentially lighting, camera, and then an industrial PC running the vision software. You can have a higher camera count. You can have actually up to 16 cameras per instance of software. Really the same as the box style controller as far as lensing and lighting options. That's really the same. And the most capable tool set and programming flexibility, not necessarily from the perspective of you can do more applications. What this really does is takes you to the next level where it's, let's call it, for lack of a better term, access to the source code of being able to modify how the program looks and feels and functions, different types of macro programming, custom calculations, a number of different options as far as your graphical user interface modules and that. So what this software and hardware platform does really allows you an extremely large amount of flexibility within the vision application. Hopefully I'm not going too fast, so just kind of want to stay on task for you guys. So managing a successful vision application. This is really something that it may seem like this is especially towards the bottom, that this is a salesperson perspective, but in all reality, what you don't want to do as an engineer at your organization is, start out and really end up with what turns out to be a science project. And the reason is because the proper steps weren't identified up front. So the very first three things that anyone should really ask themselves about a machine vision application is, can I physically identify what it is that I'm looking for? So, the famous response that I've gotten over the years from customer is, well, here's a good one. If it's anything other than this, it's bad. And the thing to keep in mind is that the major distinction between machines in general, and especially machine vision, and the way our brain works is discretion and rationalization. So we maintain those characteristics where machines don't. So if you can't identify the specific nature or a very definable characteristic, flaw, defect, however you want to define it, there's really no way that the vision system is going to do it either. So as you start to go down the road of what's good and what's bad, make sure that it's identifiable. The second thing is you want to make sure that it's quantifiable. So if you can't apply a number to it or a specification, that's an issue. And the reason is this gets into what everyone hears in the vision industry is scope creep. When you really don't have defined expectations in the beginning, you don't have a defined start and stop point. Because in all reality, as two companies go into a relationship with one another and are working on a machine vision application, they want to be able to look each other in the face and say, I'm going to tell you that I'm going to do this. You're going to pay me this sum of money to do that. And when I'm done with it, we're going to shake hands, you're going to be happy, and we're going to be done. And that's all based on the fact that we've set forth these specific criteria, standards, and quantifications of what defines the success of this application. So being able to quantify that is extremely important. And then the third piece, and I think that salespeople typically try to do this, but working on more project-based systems over the last couple of years, what we really try to do is help our customers start to understand these things as well, which is, how can you dollarize what you're trying to do? The first part of that is, the easy one is the known issue. I kind of equate this to when I used to be involved in safety projects. You always knew there was going to be an order when someone called you and said they had an accident at work and they needed a safety light curtain, right? So, and it's very similar in vision. If there's a recall of products and it's somewhat of a knee-jerk reaction, there's something that's identifiable typically there. You don't want that to happen. You typically want to get ahead of it, but the reality is that it happens sometimes. That's one way to dollarize it. Another way is risk management. potential litigation issues. When you look at, especially in the food industry, and you start to talk about allergens, and litigation is associated with making people sick or worse. So the risk management and litigation avoidance, although a little bit less tangible, just as important. Some of the more hard numbers that we typically see is reallocation of personnel. Does this mean that you're trying to go out and have people lose their job? Absolutely not. What we try to do is provide the equipment, the inspection, and the means by which the machine operates the way it should. So the actual operator is engaged with the machine, and they're not dealing with jams, and they're not dealing with random faults and all these things that they shouldn't have to, because they should be watching the process, understanding the line, and running the line. So, if we can optimize that a little bit, where we can have one operator between 2 or 3 lines as opposed to an operator per line, those are the types of things that we like to look at as well. And then the fourth one, and there's tons of these, but these are just kind of the 4 big ones as I've seen them, is really reduce QA. Have a customer just recently we did a large project for, and kind of the next segment of this project is going to be the fact that they've identified by implementing vision, they don't have to do the destructive testing that they do, which is every 5 minutes they take X number of products off the line. They do some destructive testing to make sure that those products are properly being manufactured. They spend about $20 million a year doing that. So when you talk about implementing vision on the lines that they have, it's a nearly immediate return on investment, and we're 100% inspecting their product. So just a few things to keep in mind as you start to go through the initial components of a machine vision application. So as far as the successful vision project, there's really 10 steps that this tends to boil down to, and some of them we've covered, so I'll skip through the first couple. But identifying and documenting the issue, quantifying specific tolerances and criteria. The third piece is where this that really starts to hit home is you need to start to develop a preliminary scope document detailing what the expectations are. When we're talking to a customer, if they don't have a scope document or aren't interested in developing a scope document, that says that they don't really know exactly what they're looking for, what they want to commit to, and that's dangerous. So, as from a customer's perspective, in your mind, if you don't have the information to put together a scope document that helps define what you're trying to do, it's the very first thing that you should try to do. Otherwise, your application will be sabotaged from the very beginning. The fourth piece is going to be providing a comprehensive set of samples to whoever your vision vendor is. Hopefully it's Omron. I'm a little biased. You want to request that that vendor provide a detailed report on the bench testing and the lab results. And then based on that bench testing, do yourself a favor, get an online trial. Pay for an engineer to come out with hardware, set it up on the line, let it run for a few days. Because the one thing that you're going to learn about machine vision is it's going to teach you everything you never knew about your process, because you're looking at every single product, every single time, every single shift. So go through that exercise and start to understand, because what that's going to do is start to manage the expectations moving forward with regards to the scope and the specifications. So, and then upon the successful execution of that trial, you readjust your documentation, change your specifications if required, and then you want to develop acceptance criteria. So here's where we shake hands at the end and say, here, we asked you to do this, you've done this, we're done now. The other key thing is whether it be internally, you're having somebody do it, you're doing it yourself, keep in mind that the actual vision components are really, I don't want to say a small piece, but they're not the most expensive part typically of a well-planned and executed machine vision installation. I would say on average, 30% of the project is probably vision hardware. 30% of that project is typically mechanical, and really, the balance of that is really engineering, design, testing, and implementation. So keep in mind there's a lot of dollars. So protect yourself if you're the project engineer that's trying to budget, and you're going to your plant manager and you're going to tell them this thing is going to cost X amount of dollars. Make sure you protect yourself in a way that you've taken into consideration all of the different pieces that are going to be involved in this, including what it's going to affect and tie into from either a controls perspective, maybe it's a data collection system like InduSoft. So just be cognizant of those things and prepare for that, so you look good to your boss when you said it's going to cost this, and it did, and it works as promised. So, And then once that's done, again, whether internally or with a partner, agree to a realistic timeline for all aspects of the project, set milestones, follow those milestones. This is kind of project management 101, but especially, with vision, you want to keep things on track and keep everybody on the same page. So just real quickly, and I'd be happy to send anyone this presentation after the fact. My contact information is at the end, but these are just a few key items that we typically like to see in the scope of work. You want to know who's involved, what are those people doing. You want to know, state the intent of the project. Why are we all here? Why are we doing this? Let's keep that first and foremost as we develop everything around it. And you can read through the rest: product types, defects, definition of responsibilities, timelines. These are all things that should be involved in the scope of work, and all things that are agreed to by all parties involved in that type of project. And then with regards to the acceptance documentation, again, just giving a general idea of, the type of information that, should be in acceptance criteria documentation. You want to talk about a reiteration of why you're there. You want to talk about the structure of the actual test criteria. What have we all agreed to look for, and how are we going to prove that? How are we going to document it, and then how are we going to sign off on it? So those are all kind of key things that are involved in the acceptance documentation as well. So let's talk a little bit about InduSoft. InduSoft's been an amazing partner to Omron, and then it's really allowed us to take our products and our kind of concepts and engineering to the next level through the data collection and visualization of the information that we're typically collecting with sensing and vision applications. So what it does is, let's talk about something that's extremely important that if you're in manufacturing, you've probably been beat over the head with this, which is OEE, okay? OEE, in its simplest terms, is how much should you be making per given time, taking into consideration downtime, shift time, all these different things. And really, how much are you making? And of the stuff that you're making, how much of that is good? Okay? So OEE is absolutely pertinent to the manufacturing process, and if you're not speaking it today internally, you should be. And this is just a little bit of a graphical analysis of OEE. So why am I going over this? What people typically miss is when they install an inspection system, when they install a sensor or vision system or gauging, they're typically just band-aiding an issue. They're saying yes or no, this is good or bad. What they're missing out on, and what InduSoft brings to the table, is the ability to now acquire that information, manage it in a way that's now actionable, and takes that investment that you've made in the inspection equipment and then translates it back. So you can actually start to use that as a root cause analysis tool to actually fix the problem. Kind of a novel idea, right? Coming from a vision vendor, looking back and let's use the equipment as it's intended, but then let's go back and fix the process. The best thing that, in my mind, that can possibly happen 6 months after a customer has installed one of our vision systems, and especially from a project perspective, is they come and say to me, hey, do I still get the occasional defect, and are you kicking it off? Yes. But what we've done now is we use your tool. We use the information that you provided to us through this visualization software called InduSoft, and then we took that, and now we've reduced our scrap rate, from 0.5% to 0.1%. So we still need you, but we're doing a lot better job today than we were when you first saw us. That's the best comment that we can get. So how do we get there? We talked about collection. Segregation is the next part. So not just what's failing, why is it failing? What are the specific characteristics? We can tell you that. By the way, we can tell InduSoft that, and then InduSoft can display it. So what we're really doing is we're driving down to the why part of the application, okay? Not just what it's doing or how it's doing it, but we want to know why. Why did it fail? When did it fail? What conditions were present? And be able to drive back to actually start to fix the problem. So complaints with regards to machine vision. Typically, you hear, I'll pretend that these are all complaints about our competition because we never hear these, but complicated custom interface, complicated recipe management, very little custom display capability, a lot of misunderstanding about how the system works tends to drive some unnecessary customer interaction, the sticky finger syndrome, when everyone wants to go in and start pushing buttons and trying to change things because they don't really understand how it's working. And the fact that as you install a number of different vision systems throughout your plant doing different applications, they all look and feel differently. So you kind of need a resident expert on vision just to manage your internal 3 or 4 different applications, because the customness, so to speak, of each of these systems doesn't allow for the autonomy of the actual individual operators to interface with those the way they should. So how does this happen? Or how do we fix it? So from an InduSoft perspective, now we're going to take all of this information and we're going to visualize it. So we're going to take all that kind of raw and somewhat complicated data that's coming out of the vision system, and we're going to go ahead and visualize it. And we're going to build screens around visualizing it that makes it extremely usable to the customer. When I say non-vendor specific, really the beauty of InduSoft is when we go in as Omron, as a vision system, we're talking to Siemens, Mitsubishi, Omron, Allen Bradley, you name it. And the power that InduSoft brings to the table is because of all the different, I think Scott said something on the order of 240 different drivers. There's really nobody we can't talk to. And what's interesting about that is once you install the vision piece with InduSoft integrated in, you find customers wanting to tie different aspects of their equipment back into this just to do data collection, just to start to understand more about their process and manage it. The other thing InduSoft does is that it allows you to build an interface that for a given facility can provide them the information that they want and need in a means that's extremely consistent, regardless of the application. The interface, the data, the way everything looks and feels can all be streamlined by creating a somewhat simple front-end user interface that's communicating to a somewhat complicated back-end machine vision application. It streamlines recipe control. It takes the information and makes it centralized. Whereas, typically if you just put something out on the line, it decentralizes that information. You don't have access to it. You can't see it. It's not at your fingertips. Therefore, it's not that usable to you. And then, really, we talked about simplifying the user experience. And then there's a lot of custom adjustment and options associated with that. So, again, we're taking a Band-Aid that's typically what vision is, and then we're turning it back into a manufacturing, a root cause analysis tool. And we're taking the stress out of that application, so to speak. So just a couple screenshots. I know we're running just a hair long, so I'm going to go ahead and kind of go through these. Just try to keep the customer anonymity here with respect to them. But this is actually a specific designed InduSoft program that served as a front end to a multi-camera vision inspection station and provided so much value to this customer. Their operators love these things, and there's not many people on the phone right now that can tell me that their operators love their vision system. And the reason is we provided all of the tools, the custom interface, the ease of use, all through InduSoft to give them a simple and user-friendly means by which to interface with the machines that they're in charge of running. So this is a general splash screen. This is as we started to actually quantify. This was an 8-up machine, so we quantified by lane. We started to identify what lanes were failing on a more regular basis. We highlight those. There was a lot of different interaction with this particular screen where you could, again, for propriety purposes, I didn't really put any rejected images in here, but you can click on the rejected image. It's going to tell you why it failed, when it failed, how it failed. All that information is at your fingertips. So what the operators actually started to do is they would run the machine for 5 or 10 minutes at the beginning of the shift. They would dive right back into this software and say, what is it doing? And say, oh, good, it's doing that. I know how to fix that because you provided me all the information to identify what that is and why that's happening. Again, this was another kind of a reject queue. What was real interesting about this machine is that because it was 8-up and it was an indexing machine, and we had the machine vision in the front end of the machine, we could actually detect that product well before it was made its way to the exit conveyor. So at any given point, someone could walk up and say, there's a failure, click on it, it would populate that image. They'd know when it was coming and what was wrong with it. So instead of getting a batch worth of defects, you can start to see early what's going on and actually resolve the issue. This is a real useful tool as well. What they want to do is say, I want to walk up to my screen, and if it's not networked, I want to plug in a jump drive, and I want to pick a date range, and I want you to tell me everything that happened in that date range per the inspection criteria that you set forth. So everything's essentially stored in a SQL database and then referred to through the software. So what it really did is just reference this database, dumped it out in a CSV file, and then the customer was able to sort through this in detail, exactly what was going on per shift, per operator, per product, and start to wrap some metrics around the actual manufacturing process. This is great from a maintenance perspective. This is something we also put together that at a glance you can go up and get diagnostics of what's working, what's not, and then you could drive into why that was or was not working instead of it being a guessing game. And then again, another somewhat powerful tool is we kept all the manuals resident to the industrial PC that was running the system. So it wasn't running back, grabbing your binder, thumbing through at your fingertips. You had all the PDFs associated with all the manuals, including the custom manual that was developed for the actual inspection system itself. You can tell this slide I didn't build because it's the only one that has some automated motion to it there. I'm not that apt when it comes to building a very dynamic PowerPoint presentation, so I apologize. But here's the key. You can get the information everywhere. Once you get it into InduSoft Web Studio, get yourself an internet connection. You can view it through the thin clients, through the secure viewers, through the SMAs, and it really allows, especially for the multi-site engineers who are owning and managing these projects, to have the ability to go through and see the information, have it at their fingertips, and help the facilities diagnose what's going on without even needing to be there. So just a quick recap. Properly understanding deploying inspection system throughout your process throughout your manufacturing facility really has the opportunity to improve your process. Vision systems are not a hassle. If they're managed properly, they're an extremely useful tool and can really tell you things about your process that you never knew. Your customers know because they get all your products, but you don't know, because until you look at every single one of your products, you really don't know exactly what's happening. So it's really a useful tool. And then utilizing InduSoft as that data collection and visualization tool takes that investment that you've made. And by the way, InduSoft is extremely, extremely cost competitive for what you're getting. And you've already made that sizable. You've already made 90% of the investment in the hardware, in the implementation. Make that extra 10% investment. Utilize InduSoft for the visualization and start to use that tool as a root cause analysis tool that's actually going to start to improve your process. Here's my contact information. I will say that some of the information here I actually pulled right off of our e-learning. For any of you interested out there, again, you can contact me directly, email or cell phone, and I'll steer you in the right direction depending on where you're at. Or there's an opportunity I may just help you out myself. But Omron is actually one of the largest users of e-learning, so we provide that at no charge. If you're interested in e-learning on machine vision or really any other Omron automation product, I think we have, I want to say, over 20 different e-learning modules in a number of different languages. So you're welcome to log on to the elearn.omron247.com and go that way, and then you can also visit our website as well. So that's all I have. I hope that you found this useful. I really appreciate everyone's time today. And Scott, thanks again for the invite, and we'll hope to talk to you all soon. If you have any questions, feel free to get in touch.
Rob, thank you very much. Really appreciate it. I actually learned a lot. I think our attendees will have as well. I'm going to take back presentation status here and share. And hopefully now you should come back into my part of the presentation.
Scott,
yes.
Can you still hear me?
I can.
Okay, good. I'll be just sorry for a little ad lib here, but I will be available via phone. But I need to head towards an appointment, so I won't be on the computer. Just FYI, I won't be able to refer to anything. But I'd be happy to answer any questions for the next 10 or 15 minutes here.
Gotcha. Okay. Yeah, great. Thank you. One of the things that I did want to bring up is that these presentations will be made available shortly. So if you're on the attending the webinar, we will send you out a link as to where you can receive the presentations. What we'd also like to do is have you post any questions that you may have in the chat window and or the questions and answers Q&A window, and we will try to answer those questions. Hopefully we've done our jobs and presented you all the information that you could ever want about vision systems and InduSoft Web Studio. A few things, just a few notes to point out as well, is that though I brought it up a little bit, and Rob definitely touched on it, as far as the root cause analysis and feeding back into your process or your manufacturing system as to fix some of the things that you find. I originally, in my early part of the presentation, I talked about data connectivity and how to get into that. The database connectivity and the reporting tools built into InduSoft Web Studio is where the capability to determine that root cause analysis and that feedback are really what you need. So in addition to the communications connectivity, the database, the reporting tools, the other tools that we have built into InduSoft Web Studio can help you in those as well. So I'm going to take a quick peek here to see if there's any other questions. I don't see any. Oh, there we are. There's a question. How does InduSoft communicate with Omron machine vision systems? What protocol and what type of data exchange? Rob, I don't know if you're still on. Let's see if I can unmute you. Rob, are you still there?
Yeah, I'm still here, and I won't pretend to be the technical expert. There's a lot smarter people than me on this topic, but in this case, what we're actually doing, because we had the specific example that I gave you, we actually had our vision controllers communicating via Ethernet to an industrial PC, and then we had the InduSoft SCADA package running on that industrial PC. So it was actually, and then that same information was being communicated back to an Allen Bradley PLC from InduSoft via Ethernet IP. So there was a handshake not only between the controllers and the industrial PC, but then between the industrial PC and InduSoft, and then the Allen Bradley PLC that was on the machine.
Okay. Do you know how, for example, that box vision system that you showed, how would InduSoft communicate with that box?
That was communicating via Ethernet, and to be quite honest, I don't know. The bus was Ethernet. I don't know what the protocol was.
Okay. And I'm sorry to put you on the spot. Do you know if any of your cameras have, or vision systems in general, have any of the Omron protocols or other protocols built into them?
Yeah. So the vision controllers typically have the FINS gateway built into them, which is a standard Omron protocol. I could get you a full protocol list if you were interested, but I do know from a FINS gateway perspective that's built in. Most of our vision controllers now all have Ethernet IP that are actually built into them. So, and then they typically all have serial RS-232 communication built into them as well.
Okay, great. Thanks, Rob. Any other questions? There's another question. Is it possible to share images between the vision system and InduSoft? I can't speak for Omron specifically, but I know other vision systems, we can collect data out of them, say bitmaps or JPEG, and some of the vision systems that are out there will allow us to collect that data either via a database connectivity, maybe there's a database stored directly in the vision system, or it will store the images remotely, or potentially we can receive a bitmap image and store that off within InduSoft Web Studio in our own database or some other database connection. So is it possible to do this? Yes. Rob, do you know if that's possible with any of the Omron vision systems?
Yeah, it is. And actually in that application that I was showing you, we were doing that. So we did. What we didn't want to do is burden the vision system by dumping every image at every inspection into InduSoft. So what we actually ended up doing an occasional, we did a buffering of the images, and then we dumped them in between processing. So we had basically a constant timed dump of images into the InduSoft program. So we absolutely can do that as well. We were doing it on that application.
Okay. And I have seen through other applications that I've been involved with, let's say the application is a pass-fail, you might only store the images on a failure and capture the bad image because a good one is obviously good. Or if there's statistical process control involved, maybe you take certain samples. If there's a rapid manufacturing happening, maybe you take certain samples so often, so many samples so frequent, and gather those images and store those off as well. Let's see, any other questions? Right now we don't have any in either the chat window. If you have those, again, put those in the chat window or the Q&A window. We'll be happy to try and answer those. Just some more notes. As I mentioned before, the presentations will be made available. We'll send you the links for those. We will also, after this afternoon's webinar, determine whether or not the afternoon of the webinar or morning webinar was better, and record that to a video, post that on our website and on YouTube within the next few days. So we'll send you links to those as well. So at this point, I don't see any further questions, and I really want to thank everybody for attending, and hopefully you learned something. I know I did. There's a slide up now that shows you how to contact InduSoft if you have any other questions. Rob's presentation has his contact information if you need to contact Omron or him directly. And let's see, just to make sure. Let's see, one more question came in. Is it possible to save the images with marks like OK or no good? So I know that InduSoft Web Studio can save images, but let's see, OK or no good. So Rob, I don't know if your vision systems will append or add annotations into the images themselves for good or no good, pass or fail. Do you know?
Yeah, absolutely can. There's a couple different ways to do it. You can do a screen capture image and store it that way, or with the new Giggy Base equipment, the FJ software has the ability to put in some custom notations as well. So there's actually a couple ways to skin that cat, but yeah, absolutely that can be done as well. So you can start to drive back into, from an image perspective, what was wrong, not just pass or fail, but why was that image bad.
So additional information as well. Great. Okay, with that, I would again like to thank you, Rob, for the great presentation. I enjoyed it. I learned some things. Hopefully our attendees did as well. And I would like to thank everybody for attending. I see and recognize some names from some people who are not based in North America, so they're either up early or up late. And I want to thank everybody for attending, and hopefully you had a great time, and we hope to see you in further webinars at a later date. Thank you, and hopefully everybody can have a great day.
Thanks, Scott.